Hello. Today we're going to be solving one-step inequalities. And so what we did was we talked about what does it mean to be equal, and it means to be the same. And so we said in something that is unequal, then the in means not. So inequalities are not equal. And so we have some symbols that help us figure this out and help us to show this when we are working. So if I have this symbol, that means whatever is on this side is less than whatever is on this side. So I could fill in a number like 4 is less than 6. And something that we're going to start seeing is a variable in there. So we might see something like x is less than 6, meaning that x could be anything as long as it is less than 6. The next symbol is the greater than symbol. And so I could say that 6 is greater than 4. That's a true number statement. And I might see with a variable, I might see y is greater than 10. And that means y could be anything as long as it is greater than 10. This is the less than symbol again, but you notice this little line underneath it. And that means that x is less than or equal to whatever is on this side. So say I picked 12. Well, then x could be 12 and anything less than 12. So this is the less than or equal to symbol. And words you might see to express that are no more than or at most. And I like to think of like my kids going to the playground, and it says only kids under a certain age are allowed to play there. So kids 12 and under, or 5 and under, or you can only eat on the kids' menu if you are this age or younger. So that's what my less than or equal to is going to show. My greater than or equal to, a good example would be I can drive when I am 16 or older. So I'm at least that age. Or it starts at a certain amount of money. So I might have y is greater than or equal to 16, and y might represent the age you need to be when you drive. So this is greater than or equal to. I can drive at 16 or older than 16. And this is not equal, meaning everything except that could be an answer. And when we have an answer to an inequality, when we have an answer to an equation, we're only going to have one possible answer, or sometimes an infinitely many possible answers, meaning any number, or I might not have any possible answers. Well, when I graph inequalities, it's always going to be from a certain point to positive infinity, or from a certain point to negative infinity. So it's always going to be a half of a number line might be the way you want to think about it. When I have an inequality that does not have the little line underneath it, I'm going to graph that with an open circle, meaning I'm not including it. It's not included in the group. If I do have that little line underneath, I'm going to have a closed circle, and that means that I'm including that answer. So this one you can see right here, I have x is less than 3. This is an open circle. And then the less than means anything less than that would work. So I would shade this part. You could also, if I have the variable on this side, my sign tells me which way to shade. It's like an arrow pointing me in that direction. On this one over here, we have that little line underneath, so I have a closed dot. I fill it in because 3 is a possible answer. And then it's still telling me less than, so it's still telling me to shade in that direction. So this note right here, make sure your variable is on the left in order to use these. So if you solve a problem and the variable is not on the left, that is going to mess with your graph. It's going to be the opposite of what you think it would be. So you can always flip it around. So for instance, if I saw this one and it was 3 and the x was on that side, when I flip it back around, I need to make sure I flip the direction of the sign to make sure that it stays a true statement. So down here, you're just going to practice graphing these. So I want you to pause this, try these out, and then start it up again and then compare and see if you got it correct. Our first one here is x is greater than 5. Now, you don't have to put all the numbers on the number line. So I'm just going to put the ones that go around it. Now, my symbol, I'm going to be at the 5, but I don't have the line underneath. So I'm going to have an open dot. And then my arrow is telling me it's greater than. It's pointing that way. So I'm going to shade in that direction. My next one, x is greater than or equal to 6. So I'm going to do the same type of thing, 3, 4, 5, 6, 7 here. I do have a line underneath, so I'm going to have a closed dot. And it is also, though, pointing this direction. My next one there is x is less than -3. So I put -4, -3, -2, -1, 0, just to give me an idea of where I'm at on the number line. I'm going to have an open circle, and it's telling me less than, so I'm going to go that direction. My last one, notice that the variable is on the wrong side. So I want to flip it over here. I'm going to put b on this side. It was a less than or equal to, so I'm going to make it a greater than or equal to, and then I can put my 4 over there. So I'm going to go 1, 2, 3, 4, 5. I need a closed dot there, and it is telling me to go greater than, so it's shading to the right. Now, with what seems to be all things in life, there seems to be exceptions to rules. So when we do this, we've been solving equations, and we know how to solve one-step equations. So if I saw this and there was an equal sign, 2x equals 6, I would solve it by going, oh, I divide by 2. And I would find that x equals 3. We're going to do the same thing, only instead of x only equaling 3, x is going to equal anything less than or equal to 3 in this case. So when I divide by 2, I'm going to get x is less than or equal to 3. So 1, 2, 3, 4, 5. I'm going to go to the 3. I am going to enclose that circle, and it is telling me to go that direction. Now if I take that same problem and I have a -2 in front. So this time, if I had -2x equals -6, I would divide by -2, and x would equal a +3. Same thing's going to happen here, only when I divide by a negative, I have to flip my symbol. If I were to go back and plug in something greater than 3, where the x is, I will get a true statement now because I had to flip the symbol when I got the answer, but I don't flip it back up there when I check it out. If I didn't flip it and I went to check it out, it wouldn't work, and I'll show you that here in just a moment. So we've got 1, 2, 3, 4. I've got a closed dot. It's telling me to go anything up here could be a possible answer to that. If I substitute in -2 and I pick something greater than 3, I'm just going to grab 4 here. It's greater than or equal to -6. And I'm sorry, less than or equal to -6. And I would say -8 is less than or equal to -6. That is a true statement. If I had not flipped that, I would have been going on my graph this way. And so maybe I would have picked 2. So I would have said -2 times 2 is less than or equal to -6. Well, -4 is not less than or equal to -6. So that is why when I divide by negative, I need to make sure I flip my inequality symbol. So take some time and think, what have I learned here? How could I put this into my own words? How can I explain this to somebody who hasn't seen it before? So go ahead and pause and write some thoughts down there. All right, on the back here up at the top, all you're going to do is going to tell me yes or no on these first 4. So you don't have to actually solve them. So if I look at this equation, and I know it's a two-stepper, it's a cheat, but if I look at this equation, I'm going to end up having to do some division with a +2. Since I'm dividing by a +2, I do not flip my symbol. On this next one, I'm going to have to divide by a -4, so I do flip my symbol. +4, I do not flip my symbol. I would have to multiply here by a -2, so I do flip my symbol. And this last one I would be dividing by a +2, so I do not flip my symbol. So if I have an inequality that looks like an equation to solve, I'm going to solve the inequality like an equation. That's just like I was showing you on the front. When multiplying or dividing by a negative, I need to make sure that I flip the sign. I then graph the solution, and then I'm going to substitute in one possible solution to check my answer. Alrighty, so down here, like we said, solve the inequality like an equation. Flip the sign if I'm multiplying or dividing by a negative. It's the only time I'm going to flip the sign. Then we're going to graph the solution. We're going to substitute one of the possible answers in, because remember, you're going to have a whole bunch of possible answers since it's an inequality, and see if you got the right one. So just like I would solve an equation, I'm going to add 2 to both sides. Those cancel out. Now my sign was a greater than sign, and I just added or subtracted, so I don't need to worry about flipping that sign at all. So I got that Q is greater than 16. So remember, on here, I don't need to count all the way up to 16. 13, 14, 15, 16, 17, 18. Totally good enough. Now, it's greater than 16, so I'm not going to include it. I'm going to put the open circle there. And greater than, do you see how it's pointing that way? And my variable is indeed on the left. So I'm going to shade that direction. Now what that means is I should be able to pick anything over here, put it back into my equation, and it should be the right answer. So, or a true answer. So I could pick 17, 18, 19. I could put 16.1, whatever I want to put in there. So say I pick 17. Well, my original equation was Q minus 2 is greater than 14. If I put 17 in there, I get 15 is greater than 14, which is a true statement. So that means that my answer and my graph, if they match up, should be correct. My next one here, I have my variable on this side. I'm going to want to flip it over to the other side. You can take care of it at the beginning, you can take care of it at the end, whatever you feel comfortable with. Whenever you flip with the variable, though, in the equation, all we had to do was switch sides. When I flip and it's an inequality, I'm going to have to flip the inequality. I'm going to add 5 to both sides here because I was subtracting it. Now, -1 plus 5 is 4. So now I have this. You notice my variable is on the other side. So I'm going to flip. I'm going to move my x over here. I'm going to move my x over here, and I'm going to put my 4 over here. Now when I do that, I need to make sure that I flip my variable. Because x was greater than or equal to 4 here, I need it here to be x is greater than or equal to 4 as well. So 1, 2, 3, 4, 5, 6. I'm going to go to the 4. Now it's a greater than or equal to, so I'm going to fill that in. And it is pointing that way. So any answers greater should work. So if I put a 5 in, so -1, I would get -1 is less than or equal to 0, and that is a true statement, so it must be the right answer. I'm running out of tape time to do all of these, so I'm going to pause it and do them, and then I'll let you put it back on and look at the answers. So actually, I think I'm going to go ahead and show you how to solve this one. I am dividing by a 5, and I'm going to think of it as negative because I need to get rid of this negative. So I'm going to multiply both sides by -5. Now, as soon as I multiply by a negative, I'm going to have to flip my sign. Over here, I end up with 10, and over here, I end up with just the x. So x is less than or equal to 10. I want you to look at the one below this here as well and see what happened there and how that worked. So make sure you pause this and check out those answers. and let me know if you have any questions.